Hi, welcome to the mathcenter.com. We're going to work through some maths practice problems in this series of videos. 0606 IGCSE additional maths. We'll go through some practice problems and go through our work in general with the next few videos. On the board here, I have a problem. I'll tell you about the question, and then we'll talk broadly about the solution, and then you should be able to work things out. Okay. Please follow me on YouTube. Give this video a like and share as much as you can. Please visit the mathcenter.com for all your course needs in maths, physics, accounting, IGCSE, A levels, and IB. Okay, great. Let's look at this problem, right? Y equals to ln x over x plus 1. Yeah. So you asked to find delta y when this is not the way the question first appeared in the problem. I have paraphrased it to suit us. Yeah. Find delta y when x decreases by 3% when x equals to 1. Okay. So first off, let's talk about the principle, right? The idea will be we are looking at delta y over delta x is about equals to dy dx. Therefore, delta y is approximately equals to dy dx times delta x. So this is the idea that we are going to use. Okay, so you can see that we need dy dx. So why don't we go and work that out first? So y equals to ln x, excuse me, over x plus 1, then dy dx will be equals to, let's use the u over v. I have x plus 1 squared. Then I'll write x plus 1. Then I'll differentiate u, which is 1 over x. When you differentiate log x, you get 1 over x minus log x. When you differentiate x plus 1, you get 1. Just leave it, right? Okay, so what do we get? We have 1 over x times x will be 1 plus 1 over x minus log x over x plus 1 whole thing squared. So that's our dy dx. Not so bad, right? We just used u over v. Okay. Now, so we're pretty good, and we know that when we deal with approximations, this is called approximations, right? When we deal with approximations, we need a value for dy dx, and that value of dy dx is when we plug in the value of x that's given. Before I do that, right, let me go ahead and look at delta x. What is delta x? Delta x is the new x minus the old x, right? Okay, so the old x, okay, the old x is 1, and what's the new x? Well, they say that x decreases by 3%. X decreases by 3%. So 3%, so which means it's 0.03 of 1. So your new value of x must be 0.97. Again, right, if you didn't catch it, it decreases by 3%. That means the new value of x must be 97% of the old, right? So 97% of 1 is what? 0.97. So your delta x will be 0.97 minus 1, which will be negative 0.03. All good? So you could have done this if you're very sharp in mathematics. You could have written this down without doing any of these things by just looking at this 3% decrease and you're starting with 1. Okay, never mind. So now let's come back here. We need to plug this in. Okay, dy dx. Now this is dy dx, right? I need to plug in the old value of x. So I have got 1 plus 1. Log of 1 is gone. Okay, so I have this. And what's at the bottom? 1 plus 1 is 2. 2 squared is 4. So this is 204, right? That's the value of dy dx. So now to find delta y, I'll just write this as 204 times, I know this is approximately equal to, okay, never mind, let's write approximately equal to, okay? 204 times delta x, which is negative 0.03. So you get your answer as negative 0.015, and we are done. Half of this, so we have negative 0.015. Okay, That's it. Yeah. Thank you very much for watching. Please give this video a like and follow me on Facebook and YouTube. Visit themathcenter.com for all your mathematics and physics and accounting needs. Yeah? IGCSE, A levels, and IB. Thank you.